Hello, everybody. I hope you are doing well during this challenging period of time. My name is Qinchang Zhong. I am the Max McGraw Endowed Chair Professor in Energy and Power Engineering at the Illinois Institute of Technology in Chicago, United States. I'm also the founder and CEO of Syndem LLC. Today, I would like to talk about our work on harmonizing renewable power systems for global energy freedom so that billions of people can have access to low-cost, clean electricity. Let me start with introducing myself. I was born in Sichuan, China. When I was 15 years old, I left my parents and spent 4 days on the road to Hunan in order to attend a technical secondary school. After graduation, I started working for the school as a lab technician with a dream to get higher education. It was very difficult because I had to teach myself English at first. I managed it and got admitted into Hunan University for a master's degree. In 1997, I went to Shanghai Jiao University for my PhD degree. In less than 3 years, I managed to complete my thesis and secured a postdoctoral research position in Israel. So in early 2000, I went to Israel, and after I completed my contract, I went to the UK in 2001 to take up a postdoctoral research position at Imperial College London. Several months later, I decided to study for another PhD degree. So I worked on the postdoctoral research during the day and on my thesis during night. In less than 3 years, I managed to complete my thesis and secured an academic position in a UK university. I quickly built up a strong research portfolio and became a full professor in 6 years. In order to maximize the societal impact of our research, I decided to look for a global platform. In 2014, I joined Illinois Institute of Technology in Chicago, which is a global hub. Looking back, I realized that I have been on a mission to tackle 3 global challenges. The first one is climate change, which is now known by many people. NASA predicts that large areas on Earth will exceed 45 degrees in the summer of 2100. So we have to take immediate actions in order to prevent this from happening. The second global challenge is grid stability and security. Many large-scale blackouts happened from time to time all over the world, and the consequences can be catastrophic. For example, blackout happened in India in 2012 affected about 670 million people. The third global challenge is energy poverty and energy freedom. While many people take the usage of electricity for granted, over 1.2 billion people still do not have access to electricity. Even those who have, including ourselves, there are not much freedom in selecting the suppliers. We are tied to a group of utility companies. How can we address these global challenges together? This has been a question in my mind for many years. I have found that there is a common core among these global challenges. That is, they are all tied with energy. So I decided to take a multidisciplinary approach. That is to seamlessly and holistically integrate 3 disciplines of systems theory, power electronics, and power systems. I spent many years on these disciplines. In control and systems theory, I have studied a range of different systems and published 2 books. I've been invited to give plenary talks at several international conferences, including the World Congress of the International Federation of Automatic Control, which is nicknamed the Olympics in Control. I have also represented the UK at the European Control Association in power electronics. I have published 2 books, one in English and the other in Chinese. I've also been invited to deliver keynote speeches at international conferences in power systems. I have published a 500-page book on next generation smart grids. I've also been invited to deliver keynote speeches and distinguished lectures worldwide. So with this, I have come up with a holistic solution for next generation smart grid, which is referred to as Syndem. It means synchronized and democratized smart grid. The key idea is to unify and harmonize all the players that are connected to the transmission and distribution network. For the conventional power plants, such as coal-fired power plants, nuclear power plants, and hydro power plants, there's no need to make any major changes. They can continue to be connected to the transmission and distribution network through synchronous machines, SM. For the new add-ons, like wind farms, solar farms, DC microgrids, storage systems, we can control the power electronic converter in these systems as virtual synchronous machines, so that they can behave like the conventional synchronous machines. And for the majority of loads in the cell system, we can convert the power electronic converters in the system as virtual synchronous machines as well, so that all of these players will be able to work together to maintain the system stability in a harmonious way, that they can maintain the system stability. And also, because these players will be able to interact with each other without relying on communication network. So the cybersecurity problem is not an issue. And this Syndem architecture is scalable. It can be applied for a single home system or a large public utility grid. So with this, we have been able to address the global challenge of climate change, because now there is no limit in utilizing renewable energy. We can go up to 100% renewable power without any problem. And also, we can address the global challenge of grid stability and security, because with the Syndem grid architecture and the VSM technologies, we are able to have all the system players to regulate stability and security in an active way. What is more important is that we will have finally arrived at the position to empower billions of people with access to low-cost clean electricity because of the scalability of the Syndem architecture. So all the people can have their own power generation through low-cost clean and renewable energy sources. The Syndem principle is very fundamental and powerful. It adopts the law of synchronization and distribution. The law of synchronization is ubiquitous and is one of the most fundamental laws that govern the nature. It intrigued some of the most brilliant minds of the 20th century, including Albert Einstein and Robert Wiener. In 2017, Jeffrey Hall, Michael Rosbach, and Michael Young were awarded the Nobel Prize in Physiology and Medicine for uncovering the role of synchronization in circadian rhythms. So building the next generation smart grids with the synchronization and democratization principle is the most natural way to do. The Syndem principle introduced a synchronization mechanism into democracy, which avoids divisive scenarios that often appear in current democratic systems. For example, the 2016 Brexit referendum. It will have profound impact in future social systems. The Syndem principle has also solved the problems characterized by Arrow's impossibility theorem. which is named after Kenneth Arrow, the Nobel Prize winner in economics in 1972. This will have led to a possibility theorem. So the Syndem principle is very fundamental. The Syndem principle and the work on accelerating smart grid has been recognized worldwide. I have been invited to deliver over 150 talks in more than 20 countries. This photo shows the plenary talk I delivered at the World Congress of the International Federation of Automatic Control, which is nicknamed the Olympics in Control. Our work has been widely reported by media as well. For example, Keith Schneider, who has been a correspondent for New York Times since 1982, reported the work as a game changer for grid. And IEEE Power Electronics reported it with a cover story. In order to maximize its societal impact, I have decided to challenge myself and transform my life again, this time to an entrepreneur. I founded the company Syndem in 2017, which has now gone global with customers from US, Australia, and the UK. Recently, the US Department of Energy has awarded 2 grants to the company to further develop and advance the technology. Syndem is set to advance global energy freedom while empower billions of people with access to low-cost clean electricity. We cannot achieve this by our own. So join us and work together for a better world. Thank you for your attention.